when it comes to a trinomial that gives us a leading coefficient, we want to remove this number from the equation. So in this case, we are going to remove this number from the x squared. And similar to what we did in the previous example, the constant at the end has nothing to do with the perfect square. I'm still going to leave it at the very end. We will create a trinomial that will give us a perfect square using those two terms. So this is what we are getting for now. The constant term at the end, put it at the end. We don't need it for the perfect square. We will factor out the number from the x term. Take it out of the bracket, and from here, I can use the middle term divided by 2 to come up with the perfect square in this case. When I divide this middle term by 2, that will give us a positive 2. Regardless of whether you are having a plus or a minus, you will always be adding a perfect square inside the bracket. You will always be adding a perfect square inside the bracket. And once you have added the new terms, you will always offset the new terms by undoing it. But here's the tricky part. In this case, once you add 6 squared inside the bracket, you're actually adding it for 5 times. If you want to undo it, you want to subtract it 5 times. So that's the only difference between this kind of trinomial and the ones in the previous example. We can then create the perfect square from the above. And the rest of it, it is 166 minus 180. So the rest of it will give us minus 14. And here comes the vertex of your quadratic. Your vertex in this case will now be 6 and negative 14. It will give us a parabola that opens up with a size 5 times the original. So this is how we complete the square. When the trinomial comes with a number in front of the x squared. For the next example, we have y equals negative 7x squared minus 42x plus 3. Similar to what we did in the previous example, the plus 3 has nothing to do with your perfect square. We are going to leave it at the very end of the equation. Leave it at the very end. It has nothing to do with the perfect square. At the same time, we want to remove this number from the x squared. We want to turn this trinomial to something like this. And as you can see, the x here doesn't come with a number at the front. In front of it, it is just 1 itself. We will remove any number in front of it by taking the GCF. So in this case, I will take out the negative 7 from these two terms. Once you've taken out the GCF, you can then make use of the middle term divided by 2 to get the perfect square we want. You can add 3 squared to it, or some people like to add 9 instead. It will square the number right away, which is basically what the book said. But I'd like to leave it as 3 squared. What am I missing at this time? Do we simply add a perfect square, or we need to do something to offset the change? What do we need? Negative. We need to subtract what we had. Times it by negative 7 as well. Here. In this equation, we have had the 3 square of this many times. We want to offset the change by this many times as well. So technically, we would now be getting negative 7x plus 3 square, and the rest of it would then give us the y coordinate of the vertex. Plus 3 minus negative 63. This will now give us positive 66. Use bandmass to simplify the values. Or you can put the whole thing into your calculator, and your calculator will deal with the bandmass for you. It will give us a parabola that opens downward 7 times bigger than the original size. We have a vertical expansion by 7 times with vertex at negative 3, positive 66.